Hey there, guys. Welcome back to the second part of losses recitation. I'm Shri, and today we'll be going over three different loss classes. So, first, let's look at focal loss. This is very handy or was developed for the case of class imbalance. Now, if there were 99 negative examples and just one positive one, then the model could very easily learn to predict all of them as negative. For that to not happen, there is the balance cross entropy loss, where we give higher weight to the positive class. And researchers at Meta found out yet a better way to further improve on this. They do that by multiplying the focus, the cross entropy loss by 1 minus the probability associated with the true class raised to the power gamma. Gamma is the focusing factor. And as we increase gamma, we are letting the model to focus more on the hard to classify examples. Let's see that through this chart. Blue line here represents the binary cross entropy loss, that is gamma equals to 0. And as we increase gamma, we see there's a sharper decline in the loss for the examples which are easier to classify. So the examples on the right hand of the curve are easier to classify for the model because it learns to predict with a high probability that the particular instance belongs to the ground truth class, whereas the ones on the left are obviously not easy for the model to predict that it belongs to the ground truth class. So when we make the loss very low for the ones which are easy to predict, we let the model focus on the ones that are harder to classify in order to decrease its loss further. This is again a stateless loss, just like cross entropy. That means there are no weights or biases stored here. It's just a simple mathematical formula. And the official PyTorch implementation also goes through it in the same way in a functional manner where it finds out the C loss and then it multiplies that with 1 minus pt to the power gamma. All right, now moving on to the next one is arc phase. So in homework 2, part 2, we will be training an AI model to detect human faces in a photograph, right? Now it can classify that the photograph contains a face or not. And if I were to tell you that there is another task where we need to let the model learn to predict if the photograph has the same face as photograph B, then we need not train it again. We can just simply fine tune this model through the arc phase loss to get solution to this problem. Sounds interesting, right? So the model in the classification task would have learned to represent faces. For the sake of argument, let's assume these different colors represent a particular face and the different instances of it in our data set, right? Now, to find if two instances are of the same face, I guess the immediate thought was cosine similarity, right? But we can see due to magnitude, F1 and F2 would be more similar than F2 and F3. That's wrong, right? So this doesn't work. Then how about we just get rid of magnitude? We depend on only the difference in the angle between them. Well, that's the intuition behind margin-based losses, arc phase being one of them. So softmax just learns to separate the two classes, segregate them, have a boundary between them. And since we are looking at the angle between two vectors between these classes, we would gain by having a large margin of separation between the two classes as well. This is what margin-based losses do, arc phase being one of them, and with a very convoluted formula here, but don't worry, you will be able to implement it during the homework assignment. To give you a quick heads up on how the pseudocode would look like, since this is fine tuning that we're doing on the classification loss, we'll need a linear transformation to let the model learn from alter the representation of the classification task to its current face verification task, right? So there would be a linear layer there, and then using cos inverse, you'd get the theta for the input from the image representation, then the cos theta and the softmax of the cos theta would give you something that's there in the formula, right? And when you're training it, you just simply pass the image representation through the arc phase instance or the layer and then compare that with target as part of the C loss. So now let's go over the last one, that's CTC loss. Imagine a multimodal learning task where you're given a video where each of the frames of the video contains a digit, and we need to predict what is the actual number that's contained within this video, right? Now, we do not know what is the exact digit contained in each frame. We do not have the target for that or the output for that. We just have the total final output. right? So our task is to predict the digit for each frame, which we do not really know what it's going to be. So in such cases, connectionist temporal classification loss comes in handy. It's used for sequence to sequence tasks where the input and output lengths are different, as is the case in this one. There will be a lot more frames than just the four digits we see in the output. So you'll learn a lot more about this in class, but to give you a quick view of how this would work, you would have the input and the target derived from the model, and then you will see that they have different lengths, right? Inputs are all 50 length, whereas the target can be 10, 15, 16, whatever, right? And the model would learn to not just go over these frames to predict the digits, but then to also merge them together and such that in a way that the final output matches the output that we already have from the task. That's CDC loss and or the gist of it. But to summarize our recitation and losses, the losses are very powerful and can influence a lot of factors about your model. They can be very simple mathematical formulas or be a stateful class-based loss like the one we just looked at. Losses can give unimaginable gains in performance and should never be overlooked. And you'll work with a lot of them, and as part of your class project, you might even end up making one of them. So, all the best for your class, and to get more on losses, you can go through the further reading. Thank you.